Alright, we're going to start off with a couple of review factoring questions here around January 20th, hopefully a little earlier if you can get to it. So here we have a trinomial we're going to factor, so we're going to put h here and here, and we're going to put k here and here. So h times h is h squared and k times k is k squared. Now this is negative, so that means that one of these needs to be positive and one of them needs to be negative. And then we want to look at factors of negative 20 that subtract to give 8. So if you're not sure, you can list all of them in order until you find a pair. And remember, these are going to be subtracted because one's positive and one's negative. So you can list them all, but I think we have a winner right here, 210. So it's negative 8, so I want this to be negative 10. I want this to be positive 2. On a factoring question, you can always multiply those back together and see if you get this using FOIL. So h times h is h squared. Here we have negative 10hk plus 2hk, so that would be negative 8hk, and then finally here negative 20k squared, which is correct. And you always check to see if you can factor again, but then nothing factors there, so we're done. We also should have talked about looking for a greatest common factor here, but we did not have one, so that was not a problem. Moving over here, and again, on these notes, I would always say if there's a warm-up, you should try to do that before you even start the video. So this is a special type of factoring. Hopefully you recognize that. That's the difference of two squares, and that has a special pattern. So that's where we take the square root of this, so that's going to be 7u, and the square root of that, which is going to be 1, and we do this plus that and then minus that. And check to see if you can factor again, but you can't, so that's it. So this is the last section of Chapter 8, and then we'll be moving on to Chapter 9, which primarily deals with right triangles. So our last lesson in Chapter 8 is about dilations, and dilations kind of fit into two chapters. It fits back into the Chapter 7 on transformations. Chapter 7 was on transformations, but it also fits in Chapter 8, obviously, because it's here, because of the similarity and proportions and things like that. So a transformation is an operation that maps or moves a pre-image to an image, and a dilation with a center C and a scale factor k is a transformation that maps every point P in the plane to a point P prime, so that if P is not the center point C, then the image lies on the ray CP. So we can look down here because reading that probably, I imagine, doesn't help you very much. So what they're saying here is if the point is not the point that's the center of the dilation, then it lies on a ray that goes back, that starts at that point, at the center. Okay? Alright, so the scale factor, k, is a positive number in our book. We will have some examples in our notes possibly where there are negative scale factors also, but all of the questions in our book only deals with positive scale factors. So that is equal to prime is the new point. So it's the new distance divided by the old distance, because P prime is the new point. Okay? So for a dilation, the scale factor is new over old. And that shouldn't be too hard to remember, because most of us would prefer something new to something old, unless it was an antique, and that's a separate kind of category. But in general, I'd rather have a new pen than an old pen. I'd rather have a new computer rather than an old computer. So, I mean, that's just a way to remember it. New over old. Okay? Now, that is a little bit tricky because now that kind of also can be confused with similar figures have scale factors also. And similar figures have scale factors that are the first thing divided by the second thing. So that's just about what order it's in. So you need to kind of remember these separately. Dilation scale factors are new over old, and similar figure scale factors are first over second. That's where we talked about like getting first place and being on the tallest metal stand. And then it goes silver and then bronze down there. Okay. If P is the center point of the dilation, then P equals P prime. So if it doesn't really make sense, but if you think about as an enlargement or reduction, if you were starting at point C and you end at point C, then you didn't really go anywhere. Okay? So by saying that mapping the point P to another point on this ray, that tells us that dilations are not an isometry. So, where I'll put that. Right here. Not an isometry. All the other transformations we learned about were isometries. If you've forgotten, not an isometry. Isometry means same measure. So not an isometry means it doesn't have to have the same measures. Okay, so identify the dilation, whether it's an enlargement or a reduction, and find its scale factor. So for a dilation, we want new over old. So the new, so we want to remember that, so new over old. So the new distance is 7, and the old distance was 3. So the scale factor is K, so K is 7 over 3. So I did that part first. And by looking at that, that is larger than 1, so this is an enlargement. Now, if we just look at the picture, so those are the two questions there. The primes are the new thing. So clearly the new thing is bigger than the old thing. So hopefully, clearly that's an enlargement. Okay. Now over here, we're going to look at the same thing. So we're going to have new over old. So the new distance is the prime. So the new distance is 3. Put the K right there so I don't only have to write that once. So that's 3. Now, the old distance, the blue is the original because there's no primes on those letters. Primes are the new ones. So, if you look at the distance from the original back to the center, it's not 1. It's actually 4. So that's going to be 4. Now, if we look at that, 3/4 is less than 1 and greater than, it's in between 0 and 1. So that means that we have a reduction. Okay. That's pretty straightforward. So, it says draw a dilation, but we have this graph here and we have some points, so probably the first thing we could start doing is graphing these points. So -2, 1 is right here. It's not actually. -2, 1 is up here. I was a little careless. So now I want to make sure I don't get tricked with that. So I'm going to go ahead and label that. We should label points. And then -6, 0. 1, 2, 3, 4, 5, 6, 0. So that's going to be B. And -1, -2. That's going to be down here. And that's going to be C. Alright, so we can start by, and this is the original, so luckily I did that in blue. Doesn't matter, I just try to color coordinate the notes here. So there is the original, and that's in blue. Now, the new points, we're using a scale factor of 3/2. So remember, the center is the origin, it said. So looking across here, this is gonna, maybe I'll use a different color. So that's going to be along that line. This line I don't really need to trace over. B is going to be on the y-axis there. And C has to be along this line here. And we have another one there. I don't know if you could, that was on the screen when I was doing that. But it says the center, use the origin as the center. So that's why I went back to that point. Alright. So if we look at those, what those new points should be, to do a dilation, all you have to do is multiply the point. If the center is at the origin, all you have to do is multiply the points by the scale factor. So 3/2 times -2, the 2's cancel and you get -3. And then 3/2 times 1 is just 3/2, which is 1.5 or 1.5. Now here, 3/2 times 6, so -6 divided by 2 is -3, and -3 times 3 is -9. Now if you think about how we were getting that, we are multiplying 3/2, the scale factor, times the point. So if we multiply that out, this is what we get. And then we do the same thing to B. We're going to have 3/2 times. So I was telling you this, but I wasn't writing it down exactly like that. So it's important when you're taking notes, you try to show some of those details. Then 3/2 times 0, that's still going to be 0. And then the last one is going to be 3/2 times -1, -2. So that's going to be -1.5. And then this is going to be, the 2's are going to cancel, that's going to be -3. So now that we have these points, we can plot them. So -3 and 1.5, -9 goes all the way out to here. So this is going to be A prime, it's going to be B prime. Okay, and C is -1.5, -3. So that's going to be C prime right there. Now, if we make connect those points, there is our new triangle. And how does the perimeter of the pre-image compare to that of the image? Well, if each side is 1.5 times as big, the perimeter is 1.5 times, wait, how does the perimeter of the pre-image compare to that of the image? Oh, they're kind of tricking that because the image is bigger. So the perimeter of the pre-image is going to be, the reciprocal of that is 2/3. How does the perimeter of the preimage? The perimeter of the preimage is so this threw me off for a second because they kind of reversed it on us. So they said the perimeter of the preimage. So the scale factor was 3/2. So we multiply by 3/2 to get these points. But now they're asking us how does the perimeter of the preimage compare to the image? The image is the red one. So that's going to be in reverse. So the reciprocal of that, the perimeter of the preimage is 2/3 of the perimeter of the image. Okay, so that threw me off a little bit. Okay, moving on to the next page. So this is a little bit of an odd question here, but I believe there was a couple in the assignment. So it says the scale factor of a dilation centered at the origin is given. What is the equation of the line through point P and its image? Okay, so because it's centered at the origin, I should say this, at the origin, that makes this pretty easy. So this is kind of weird. We don't need this for this question. Because they're just asking us to find the equation, and the line goes through this point and it goes through the origin. So we can use point slope form for that. So that's going to be or we can even think of it this way, since it's going through the origin, the y-intercept is 0. So we can just focus on y-intercept is 0, so we can use y equals mx plus b, which would be even easier. So, well, maybe not necessarily. So the question here, what is the slope? So if you think about the point 3, -5, that's going to be down 5 to the right 3. So that's going to be negative change in y over the change in x, -5/3, and that's it. Because it goes through, I should have used a ruler for that, it would have been nicer. It goes through the origin, and it goes through the point 3, -5. So if we're looking at that line that connects those 2 points, b is 0, and the slope is -5/3. So using that same kind of idea over here, because it also goes through the origin, we can use point slope form. So this one, though, is going up to the right 3, up 6, or up 6 to the right 3. So 6/3 is going to be 2. And it's going up, so it's positive, and that's it. Okay, so in the past we've had some state tests and different things, and they've had all different kinds of questions on dilations. So we have some review questions here in the notes that review some of these stranger questions. So what we want to do here is just at least expose you to these different kinds of questions that we've seen on some of these tests. So the first thing we can look at here is that we are diluted about this point, dilated, not diluted, dilated about this point. So if you compare the difference of one of those points from here to here, and the scale factor is 4, so we know it's an enlargement. So if we take this distance and we think about what's happening there, so we were at 1, and if we head towards -2, that would be -3, or left 3, I could say. Or I could say left 3. And if we look at the y, if we started at 1 and we went there, then that's up 1. So that's how we could think about it. But the scale factor is 4. So from there to there is -3, 1. But we need to multiply that by 4 to get our new coordinates. So if we do that, that means we need to go, instead of 3 and 1, we need to go -12 and 4. So if we go -12 from our center, so we're at 1, and we go -12, that'll be -11. And if we're at 1 and we go +4, that would be 5. Now, some of these are pretty tricky. So another way to look at that would be that we were at 1, 1, the center, and then we applied this -12, 4 vector, and then that would take us to, if we're at 1, this is not a midpoint thing. So we're at 1 and we go -12, so that would be -11. We go 12 to the left from 1. And here from 1 we go up 4. So if we go up 4 from 1, we'd be at 5. So that's another way of kind of looking at how to get this point here. Okay, so we're dilating about the origin, so that's right here. And the scale factor is 2. So if we take a point that we have, so this is 2 on the graph, the scale is 5 by 1s, and if we take a scale factor of 2, that would be, so 2 times 2 would be 4. So on our image, it should be 4 units away on the y-axis instead of just 2, because it's twice as. So now if we count up to 4, we have this point right here. Okay, and if down here, if this is 1, then we should be at 2. So that should be here. So dilation by a scale factor 2. So what I did was I focused on 2 easy points, the x and y intercepts. So hopefully you noticed that. That's kind of where we were focused, the x and the y intercept. And so we said, where would the x and y intercept be if we multiplied the points on the line by 2? So that origin provided us a frame of reference. Okay. If you get bogged down in these questions, don't panic too much. We haven't had the state testing really in effect much, so I can't remember what we did last year. Try to do them, but don't stress out about them too much. Okay, so dilate line M by a factor of 1/2 about point P. So if you think about it, if you have a point, out here, A, and you want to dilate it by half by P, you're going to be halfway closer to P, your new point. So the thing about that is that every point on the line just gets halfway closer to point P than wherever it is. Unless it's point P, then it stays in the same place. So what that should show you is that our line should look exactly like this line, because all the points are just shrinking towards P, but it's an infinite line, so It's just the line. Remember, lines are infinite. So if I took this line and squeezed it shorter by half, it's still infinite. So every point is coming halfway closer to P, but there's always another point out there at infinity. So, alright. Try to go through these kind of quickly. Spend a little bit longer side already. So here it says that AB and CD segment, AB and CD intersect at E. F lies on AB. AEC is 60, and the two segments are dilated about point F with a scale factor of 1/2. So if you think about it, every point gets halfway closer to F. So A, is approximating, it's going to be about right there, A prime, and E is going to get about halfway closer, so that's going to be E prime. B is going to get halfway closer, so that's B prime. Now, these other 2 points, C and D, that's a little more awkward. So, if we connect them to the center of dilation, like this, and like this, then with a scale factor of 1/2, that should be halfway. I could measure that maybe to get a little more accurate, but let's see if I can figure it out from this. So that's going to be C prime and D prime. So what is the question even asking us? So what's the measure of angle A prime, E prime, C prime? A prime, E prime, C prime. Well, if I connect these 2 points, both those points got halfway closer to this. So what I should realize is that these 2 lines are going to be parallel, and that new angle that they're asking us is going to be a corresponding angle to this. So we have parallel lines imply corresponding angles are congruent. So our angle should be 60 degrees also. Okay. In the figure, let the figure be dilated with a scale factor of k, where it's not equal to 0 or 1. If it was equal to 1, it would be exactly the same. So, does the measure of angle A prime, B prime, E prime equal the measure of angle A, B, E? So A, B, E is this angle right here. We didn't really talk about this on the other side, but if you think about what happens with the dilation, a dilation is an enlargement or reduction. If we have a picture and we put it on a computer and then we enlarge the picture, the sides all get bigger, but the angles stay the same. So this is suggesting that the angle, the new angle, should be the old angle times the scale factor. That's false. Angles stay the same size. That's definitely false. Alright. G prime would be in between B prime and F prime. So here's G, and here's B, and here's F. So if G is in between B and F, then when we shrink it or enlarge it, G is still going to be in between those two for sure. Oh, that was up here. Oops. I hope this is true. Let's see. So C prime D prime is going to be equal to K times CD. So yeah, you multiply the scale factor times the original length and you'll get the new length. So that's true too. So that was nice. Okay, let's wrap these up. 4 more. Okay. So in the diagram, boom, dilated. So what I would do is connect it to the center of dilation here. So A, and it needs to go through A prime and then back to O. And here, same thing. And I don't know if we need to draw those in or not. We'll see. Let's wait a second. So it says that this is 1/3 of the original. So that's a reduction. I don't see that anywhere, but so the original was 3 and the new one is now 1. Okay? So it's 3 to 1. So if you think about it, this big, if we look at this triangle, these two triangles would be similar. So this big triangle would be 3 to 1 here. So this would be 3 to make that to be 3 to 1. So if that's 1 and this is 3, then this side would have to be 2. Okay, so now it says what is OA prime? That's 1 over AA prime. AA prime. AA prime is right here, that's 2. So that's 1/2. Alright. Which figure is dilated with a scale of 1.5? So 1.5 is larger than 1, so it's an enlargement. So it should be bigger, but the angle should be the same as the original. So we have these 3 choices here. So this one looks smaller, so that can't be the answer. This one looks really close to the same size. This is smaller. Oops. Switch the M and the A. Smaller. Same size. Needs to be an enlargement, so it needs to be this one. So that's pretty straightforward. Okay. Last 2. I guess let me sketch a graph for this. Alright, so -4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's right here, that's A. Polygon is dilated about the point 0, 2. Okay, so there's A. That's our center of our dilation. So 0, 2 is right here. They didn't name that point. And the scale factor is -2. What's the location of A prime? So in our book we don't have negative scale factors, but a negative scale factor goes in the opposite direction. So if we look at this, to go from 5 down to here, that would be 3. And then to go over here, that should be, to go from -4 to 0, that would be 4. So we go down 3. So a normal dilation, a positive dilation, goes off in the same direction. A negative dilation needs to go in the opposite to the other side of the center. So down 3 over 4, and that's twice. So we're going to go down 3 over 4, and we would be here. And then we're going to go down 3 again and over 4. So that's going to be 4 and 4. And this is going to be 3 and 3. So if we go down 3, we're at -1, and if we go down 3 more, we're at -4 for the y. And for the x, we went over 4 and over 4 again, so we went over 8 from the y-axis. So that's right here. Like I said, do not stress out too much if you didn't follow that. These multiple choice questions should not be a big deal for you guys. Okay, so this last one here can be a little tricky. So let's see what we can do with it. Last one, let's get this done. So 5, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. So that's J. Wait, is it? J prime. You can barely see it there, but that's J prime. Is the image of J, which was at, so that's J prime. Let me see, I'm going to do, J is going to be 3, 3. Alright, so if we look at that, they want the center of dilation. So it says the scale factor is 3. So this point is 3 times farther from the center than this point is. So if we connect those like that, then the center should be down here somewhere. So if we look at this, actually, this goes 4 down and 2 to the left. 4 down and 2 to the left. So if the scale factor was 3, this is 3 times farther away. So if you think about it, if we break this down into pieces, it's like 1, 2, 1, 2. And if we did one more of those, like so, then, so now this is 1 to the left and 2 up. And if you think about it, this is going to be 3 to the right and 2, 4, 6 up. So this was over 1 up 2. This is over 3 up 6. So this is 3 times bigger and this is 3 times bigger. So this must be the point we were looking for. 2, 1. Alright. That was a long one. I'm going to go ahead and sign off here. For the last time, don't be stressed out about those multiple choice questions. It's about that time. Have a good day.